All right, so let's say somebody's helping you defuse a bomb and you pick one of the wires and then they say, oh, we read the owner's manual. The green wire is the one that you shouldn't cut, but you have to cut one of the wires. So then you think, oh, the Monte Hall problem, therefore I should switch and it's the red one. Guess what? That's actually a misinterpretation. That's a misunderstanding of the Monte Hall problem. You see, if you really think about it, why would picking one of the wires at the beginning cause it to be the other wire? I mean, if they're going to read the manual and find out it's the green one, you could just wait. Oh, it's the green one. Okay, it's a 50-50 of whether you're going to pick the red or the blue. So what's the deal with the Monte Hall problem? I thought the Monte Hall problem says when you pick one that it's more likely when you switch. Well, you see, that's why this is a misinterpretation. That's why when you see these YouTube videos where they say, "Oh, by somebody watching, if you pick one, it's magic. It's like a quantum, like the observer causes it to happen." No, it doesn't. What's happening is they're assuming that the one that the one that they read in the manual happens to be one of the ones that you didn't pick already. See, I could have picked the green one from the beginning. And if they were reading the exact same manual without any changes, without any quantum cats involved, they would still say, oh, by the way, don't cut the green one. Oh, well, I selected the green one. That's the point. The point of the Monte Hall problem is it's assuming things, a bunch of things. And that's the thing that makes it so hard for people to understand, is it's not just the math, it's the way it's worded and all the assumptions involved, especially assuming that a game show host is going to offer you the change no matter what, instead of only if you selected the correct one to begin with, for example. So, and it also assumes that the door that they remove, right, is going to be the goat or whatever, because sometimes they say, oh, they removed a door, but they don't actually necessarily say that he reveals to you what's behind the door. So that's important. If he doesn't reveal it to you, how do you know he's not removing a correct choice? So in this situation, if it was an actual real life situation where you're actually defusing a bomb, right? No matter whether you picked something to begin with or not, since that has no effect on whether the user's manual that your friend is looking into to decide, oh, don't cut the green wire, you picking a wire has no effect on that. Whereas in the Monte Hall problem, it actually, if you think about it, it actually has an effect on that, because it guarantees that no matter which one you pick to begin with, that one of the remaining choices of not the one that you picked, one of the remaining incorrect choices will get removed. So if that's magically how it works, but how would that work in real, how would that really work? I mean, you'd have to go up to it would have to be a situation where you go up to the wires and you say, okay, I'm going to pinch the green one. And then your friend said, or I'm going to pinch the blue one. Let's say I'm going to pinch the blue one off. Okay, and now that allows your friend to do like a voltage test, and he can decide, okay, using the voltage test, he can remove one of the incorrect remaining wires. Okay, so let's say I pinch the blue one. He does a voltage test and he goes, zzz, okay, I know the green one's not it. Okay, now it's actually more likely for it to be the red one, and the Monte Hall problem applies because his test is basically, it depends on which wire you picked to begin with. So technically, there's more chance of it being the red one than it would be the blue one. And that's because if you would have picked, say, the green one, he would have to do a voltage test to remove one of the incorrect wires of the blue or the red one. So there, the Monte Hall problem actually applies. You started with a 1/3 chance that the correct wire to cut was the blue one, right? Then you removed one of these two options. Okay, so that means there's still a 1/3 chance that it was the correct wire, but now there's a 50% chance